we are going to discuss parallel input, parallel output, shift register. Okay, here we are using the D flip-flop. Okay, so in order to get D flip-flop component, go to place, then click component, then press in the component D, right? So you will get this D flip-flop and click OK. Then you need clock voltage, one ground, interactive digital constant. Okay, so again, if you want interactive digital constant, go place component, whatever you want. If it is ground means you enter G and D. Okay, G and capital G and okay. Otherwise, go sources, power sources, and click ground, ground. You have to click ground. Then if you want interactive digital constant, go for digital sources, then you will get this interactive digital constant. Okay, here I have used this prop, digital prop I have used in order to see as a graph. So I need these prop. So you have to press this one, you will get this, right? You have to place it on the wire. Okay, so in order to see output as a in the separate graph. Okay, so parallel output, what it says, we are feeding the inputs, all four inputs, because this is a 4-bit parallel input parallel output. We need 4 flip-flops, so we are feeding the for all the 4 flip-flops at a time, right? Here we are feeding all 4 once for the all 4 D flip-flops. Okay, so here set and reset pins is optional. Here I have not used. So based on your requirement and application, you can use set and reset pins. Here I'm not using set and reset pins. So we have one input and along with that clock input. So here I have used a digital clock. Then Q and Q bar our outputs. So here we are taking the output only at the Q. Here I have connected the props. Okay, we can visually see the result by using this prop. So we can see the result as a graph. Okay, as a waveform. Okay, see, just once if your circuit connections are done. Okay, so here we are, for all the flip-flop we are giving the global clock, right? So as we did in our counter, right, we have given from the previous flip-flop output, right, as a clock signal. Here we are giving for all the flip-flop global clock. Okay, so here the output of the first flip-flop we are giving as a input to the second flip-flop. Similarly, for the third flip-flop we are giving a output of the second. For the fourth flip-flop we are giving output of the third flip-flop. So once if your circuit connections done, just run your circuit. See here, so this is your transient waveform. In order to achieve this, you have to go for simulate and click analyze and simulation. In that you have to click transient and you have to change. Initially it has 0.001. How to calculate this one? Here our frequency, see here our frequency 1 kilohertz. So T is equal to 1 divided by F. So 1 divided by 1 kilohertz is 1 milli. So here I need 5 outputs. So that's why I have changed it from 0.001 to 0.005. Once if you are, it has done, so click save. Then you have to press run button. Then only you will get this graph. So as a waveform. So the first one is a clock, right? So this is a positive pulse, this is a negative pulse. The remaining 4 lines are your output, right? So this is your PR2, PR3, I mean the first flip-flop, second flip-flop output, third flip-flop, fourth flip-flop output. See here, for the first clock pulse, your first flip-flop receive 1, right? For the this is as it is a parallel input parallel output for the first clock pulse itself. So all the flip-flop receive the inputs and it gives the output. So as it is a parallel input and parallel output, right? So this is the graphical representation of your output, and also you can see your result here itself. See here. So once if you are feeding the input for all the flip-flop at a time, you will get the output at the output of each flip-flop. This is your PIPO simulation. Thank you.